Hello, my name is Evan Sinisak. I am recording this video demo for my Info 6045 Animation Project 1. The main purpose of this project is to implement keyframe animation and showcase the different interpolation methods and have multiple animations playing at the same time. I still don't understand this main animation time not global. Anyways, so I'm just going to go through the code real quick. For the most part, the keyframe animation stuff is based off of or almost exactly the same as the stuff we did in class. I just find that for me, when implementing stuff like this, and you'll see it in the physics project as well, I like to make game objects or entities that has the new properties of whatever we're working on. So for example, for this project, I made a new animated entity that gets played through our animation system. But so the first thing is this make animated entities function, which simply goes through the process of making the entities and giving them their animations in this scene. And the reason why I do it like this is so that eventually later, when I make a factory and or a factory builder, I already have the process down, and I can just put it into that later. So to make each animated entity, you make it as a pointer, give it its position, rotation, scale, and color of its initial, and then you have to implement its mesh. So when doing it as a factory or builder, the mesh name, the position, color, rotation, and scale can all be passed as values to the factory. And possibly the other mesh properties. But for this project, to keep things simple and to show the 3D of it and the actual rotations and everything, I kept things wireframe, not lit, no textures, anything like that. So that's all you really have to do to make the animated entity. So the first one I called root. It's going to be the base of a second, or it's going to be the parent of the child one entity, and then I made another entity with its own animation to show that multiple animations are being played at the same time, other than when they're just parent-child. So then I have these isolated areas. So this is to make each specific animation. You make an animation pointer and call the animated entity add animation. Then you can give the animation its time, duration, whether it's playing, its base animation speed. So every animation has a base speed, how quickly it'll move through the animation, and whether it will repeat or not, so that, and I just make them all true so that in the scene everything is just continually looping. Then on the on the animation itself, we have the keyframe positions, keyframe scales, and keyframe rotation vectors. So for this first root animation, I'm going to make the position, it's going to stay in the same place, it's going to stay the same scale, but it's going to rotate from 0, 0, 0 to, or 1, 0, 0, 0 to 0.701. There should be an F there. 0, 0, 0.7071. All with the easing type ease in, and I believe for we'll get to what the 0 or 1 here means, but I believe that is, I believe I kept the rotation the same for all of them. Then for the first child animation, same thing, and it has the exact same rotation, so the child will rotate as the parent is rotating, and we'll see the parent rotate as the child rotates. This is the same one that we did in class, just with 2 objects instead of 3, or instead of 4. So for the second animation, it is going to move from its start position to 510 in world position. The scale is going to stay the same, and the rotation is going to stay the same. And for the child, it will stay in the same position relative to its parent, but it's going to scale to double its size and keep the same rotation. Child, for animation 3, the animation will be 10 seconds long, and for the first 5 seconds, the position will stay the same, and then for the next 5 seconds, it will move to -7.552 in world space. And for the second animation, we're using ease out, and for the third animation, we're using ease in out. And the rotation is going to stay the same for all 10 seconds. For the child animation, the position will stay the same throughout the whole thing. The scale will stay the same for the first 5 seconds, and then halve in the second 5 seconds, and it will rotate for the first 5 seconds and then stay at that rotation for the next 5 seconds. And for the fourth animation, we're going to use no easing type, and for the first 5 seconds, the root entity will move from its start position to 0, -0.5, -3.2, and then for the next 5 seconds, it will move to 552. The scale will start at its base, and then get divided by 1.5, and then get divided by half, and it will rotate a little bit in one direction and then back a bit, all with easing type none. And for the child, it will move from its base position, and for this one, I just decided to try adding a vector. So the child 1 position is basically its position offset from the root position. So this is now a new offset from that, going from its position to -0.5, -3.2, and then even farther to 552, which I think might be the same numbers I used for the root. And it will, while the root is getting smaller, the child will get bigger by the same scales. I just wanted to see if that would make the child stay roughly the same, since its scale should be relative to the root scale. And then it will rotate these amounts. And then the fifth animation I made is for that second entity, so it is completely separate from the root and child. So we add the animation to the second entity. This one I gave a animation speed of 1.5. So it will be playing a bit faster than all the other animations. It will also be 10 seconds, and it will move from its base to 2, -0.5, 2.5, and then from there to 555. And its scale, it will first get smaller, and then it will get bigger. And then for the rotation, it rotates a bit one way, and then it rotates a bit different in a bit different way. And all these are using ease in out. And we make sure we set the parent of the child to the root, and then push our two animated entities onto the vector. Which I'll go through why we need this vector later. So this is all just graphic stuff. The other meshes I have in the scene. Just graphic stuff, drawing all the meshes. So I guess I should do this. No, because I'm drawing them right here. So for running the animations, the way I'm handling it is just in our main draw while loop. I reset the map model, and I tell the animation system to process all the animated entities using the mains delta time, and then we go through the vector of animated entities, calling update, which process. I'll go through what process and update do later, but they are different. And then we draw each mesh of the animated entities after it's been processed and updated. And then the scene is drawn, and that's it for main. So for the controls of this, we needed the right arrow key to move to the next sequence, the left arrow key to move to the previous sequence, 1 to 5 animation speed, which I made global because, again, I don't understand what this means, but basically the way I'm handling it is each animation has its own animation speed, and then there's a global animation speed that handles this 1 to 5 times the individual animation speed, and space to pause or play all the animations. So the way I decided to handle this, escape will close the window. When you press space, we go through all of the animated entities, and we go through and then we go through each entity's vector of animations, and we switch them from playing to not playing, or we switch from not playing to playing. We also needed a button to play the animations in reverse, which I will get to in a moment, but the button to do that is backspace. And then keys 1 through 5 will change the global animation speed multiplier. So pressing right will go through all of the animated entities, and it will switch the animation index in each animated entity to the next greater one, and then we check if it's greater than the size, then we go back to the beginning at 0, and then we go through all of that entity's children, if there are any. Pressing left we'll do the exact same thing, but subtracting from the animation index, and if we're less than 0, we go to the other end of the vector and then go through all the children. And I think that's it in callback. I think the only thing in input handling is that I went to my fly camera, which you can look through this if you want. It's a pretty basic fly camera that I got from this Learn OpenGL page. But anyways, so my animation.h, same thing as what we did in class. It's just a structure with all of the variables and can't think of the word. All of its properties, all the needed properties in it. So entity is just my base entity class that anything I make gets inherits from, which just has an update. So my animated entity, I tried to do a mix of what we had in class, because while I like the components, I like the templated components, and I see how they're good for future, I didn't want to implement the entire system. One, I didn't want to implement the entire system for this project, and two, I wasn't sure if we would be allowed to, since that is not required for the project and is not something that we've been working on or done in class. So I did a kind of Frankenstein of it. So my animated entity has its update, set parent, remove child, add child, and has a vector of children, which is, and it has a friendly entity ID number and its friendly name, the boolean to say if it's active or not, a pointer to its current parent, this is everything above this is stuff that was in the how we handled the entities in the code from class, but without the component system or even the system hierarchy stuff from the classes code. I need to handle the animation separately, in that I am just going to have a vector of animations on each entity, as well as a pointer to its mesh, a function call to add the animation, and then the animation index, which will keep track of which animation is currently playing, and then its position, rotation, scale, and color, and a vector of children. So into the meat and potatoes of the animated entity. Gonna start the index at 0, is active at true, and current parent null or 0. The rest of it doesn't need to be initialized, since we're always going to make the mesh whenever we make the entity. In update, we update the position, orientation, scale, and color to the position, rotation, scale, and color stored on the entity. And then we go through all of the children and call update on them. Get children just returns the parent. Set parent sets the new parent and calls add child on the parent. And add child and remove child are basically the same as in class, with one important addition. I also set the meshes children and remove it from the children's meshes. This is important for drawing the entities, because in the draw object function, we go through each mesh's children. So this lets me handle children as children and not I don't need to add them to the update sequence and process sequence separately. So animation system, basically this No, I'm pretty sure it's pretty much the same as what we did in class, with the change that since I don't have the component system, I have to specifically look for the animation stuff specifically on each animated entity rather than just a list of entities. Anyways, go through, grab the animation, position, rotation, and scale of the current entity. Make sure that it's not null and that it's playing. So here, each animation has their own speed, and that gets multiplied by the global animation speed, as I discussed in the callback stuff. And then the rest just goes through and updates the position, updates the scale, and updates the rotation. All pretty much exactly the same as we did in class, with the difference of that rotation can be handled using ease in out stuff or the lerp and slurp interpolation. For now, I just left everything using the base and the regular ease in and out stuff, but we can easily change the rotation to use lerp or slurp. And then updating it and sending the values back to the current entity, and then running through the process of all of the children. So all the fines are exactly the same, and keyframe has the easing types. Yeah, this is exactly as we did in class. Keyframe position, time position, easing type. Scale is time, scale, and easing type, and rotation has time, rotation, easing type, and interpolation type. Which I was exactly where I wanted to be. So you can run this in debug or release on x64. I'm running it in release right now just so that it goes a bit faster. I don't think I changed anything, so it shouldn't take too long. So, because of the fly camera I'm using, you use the mouse to look around, WASD to move the camera around, E and Q to raise and lower it. So here we can see the green turret wireframe mesh is the second entity. It just has this one animation where it kind of just rotates, grows, shrinks, and grows. And here at the center, we have the root and child one. Like I said, the first animation, they both rotate. So we can see the root is at the origin and it's rotating to our right. And if you look at the wireframe triangles carefully, you can see that the child is rotating as well as rotating along with the parent. So the second entity only has one animation. So when I press the right arrow key, only the root and child are going to change. So this is the second animation. The first one was using ease in. This animation is using ease out. And you can see that it just moves and grows. The third animation uses ease in out, which is why it's green. And first part they grow, second part they move and shrink. Fourth animation, I don't know, I think I'm basically doing all three, position, rotation, and scale, the entire time. And if I press right again, we're back to the beginning. And if I press left, it keeps going. And it it goes from wherever it left off. So if I press right now, the child one was kind of in line with the line in the floor. So if I press left, it starts right back where it was. If I press space, every animation in the scene gets paused. I found this was easier than just handling whichever ones were active. And if I didn't handle it this way, then things got a bit confusing. So now if I press right and left, nothing happens. And when I press space again, every animation will go back, and it's going to start updating the meshes and where they are again. So the other thing is backspace plays each one in reverse, which I just realized that I forgot to actually go through. And this handles just the current. Yep, it handles just the currently playing animation for the root, which I'm not sure why I did it that way. I thought I did all the animations, but it was probably for simplicity. Anyways, since I forgot to go over that, I'll do that now. So the reverse animation, goes through active entities and bubbles the keyframes of the current animation to play them in reverse. So 3 nested for loops. The first one is to go through the list of entities. The second no, it should play all of them. Where am I thinking? Anyways, second for loop goes through the vector of. Oh no, that's right. I'm never going through the vector of animations. I'm going through the current animation index, and I'm going through the positions. If I wanted to go through the vector of animations, there would be a 4th nested for loop, so I decided to just stop. So the second for loop goes through the list of keyframe positions, and the third one goes through the rest, starts at the beginning every time and stops after each one has been bubbled up to the top. I decided to handle it this way rather than trying to actually tell the animation system go in reverse. I thought it would be easier to just switch the order of the list of animations. So this is just a basic bubble sort. And I use keyframe positions, but so I should, and this is a fault of my own, a bit of laziness and a bit of time save. I should have separate for loops for position, scale, and rotation. I decided to just use positions and ensure that they're always the same size, which is why even when the position or scale or rotation doesn't change, I make sure that there is a keyframe at each specific keyframe. And then, just make a temporary one of each type, switch the 2 current ones, and switch the frame time so that the list is always 0, 5, 10, but which animation is at 0, 5, 10 switches. And then do the same thing with scale and rotation. And then have to do another for loop for all of the children, doing the exact same thing. So, real quick, I want to show just how to make a new child. So, I'm going to make child 2, it's going to be the exact same thing as child 1. And it is going to be higher up. Oops. And child 2 dot parent group. Nope. Child 1. I don't think I'm going to make a new... This process is basically going to be the same for each. For making a new entity. Just skipping the... parent part. So for the first animation, I'm going to just keep... you know what? Let's do this a bit lazier. For each of these, I am just going to make child 2 have the exact same animation as child 1. Just to see what happens. And obviously you can change any of the properties to make the animation do whatever you want to the... Oh shoot. Animation 3. Animation 4. Like I said, this process is exactly the same. You just have to have all of these things set. So now, after I finish this, and yeah, having a factory would make this so much easier. Because I could just call the factory. Hey. Make a new animated entity with all these properties. So, yep. And it's going to go through the floor for this first one. Oh, and I forgot to show the global animation speed. So, if I press 2, the speed is now doubled. 3, the speed is now tripled. 4, the speed is now quadrupled. 5, it's now quintupled. But 5 is a little too fast. So now the new child is also rotating around the parent. And if like I said, it's a global animation speed. Each animation does have its own. So the turret is moving at 1.5 times speed, while the spheres are all moving at 1 times speed. And this is back at 1 times global animation. It just affects all of them. So if I press 2, apparently the easing type is not changed. That's wrong. It's not going through the children's children. I need to handle this a different way. Pressing the arrow keys is not moving child 2's because it is a child of the child. Which means that's not going to work either. Well, to fix that, because of how I'm handling it, now this is more complicated than it needs to be. Fixing that, I would have to do this. But again, I need a new way to handle the children. I need them in the vector of animated entities, but if I have them in the vector of animated entities, that messes up the process and drawing. I need a recursive call. I need to make these recursive calls. I'm going to do that off of recording. I think that's everything in terms of requirements. I did not end up doing the bonus. So, yeah, that's going to be it. I'm going to change the left and right and the reverse animation to be recursive calls. Yeah. All right. Thank you for watching. I'm going to do that, clean it up a bit, and submit it. Bye.